The next thing we're going to do is called washers. So we've been working on this idea that we have some sort of function out there, and at every spot here, f of x tells us basically the radius of a circle that's being rotated around here. And if you stack up all the circles together, you have this kind of vase shape. And then when we integrate, we would find the volume. And we did this by going from a to b, the integral a to b, and we did pi, the function, squared dx. And also, if we wanted to, we could do it with respect to y, and so we would basically do the same thing, except the equation would be in terms of y, and it would be dy. So, what is a washer? A washer is basically the same thing, except instead of having just one function, we're going to have two changing functions like this. So we'd have one f of x up there maybe, and another f of, or g of x, say, right there. So when I rotate f of x around, it's going to create its own shape like this. But then this green one inside is going to create kind of a hole inside of it. Now, this takes a little more work because when we were doing area between curves, we just had to do subtracting. But it's a little more complicated with that with area. Back in geometry, if you had, for example, like a target situation and you were trying to find just the area outside here, so basically we're just trying to find the area on the front of this, we're not trying to find the area in the center. What we would need to do is we would need to take the outer radius, we'd have to do the area of the big one, so let's call this big R, and we do pi big R squared, and then we would take the area of little r. So the area of the smaller one would be pi little r squared, and then we would subtract them. The thing that people would try to do is they would try to just do r minus little r, square it, and then we're good. But that is not going to work here. Also, at this point, what we do is we factor out a pi. So we have big R squared minus little r squared. Now, in our situation here, we're going to have the blue being f of x, and the green being g of x. And so we're going to have the same sort of setup. We're still going to go from a to b. We're still going to have a pi there. But instead of just doing f minus g and then squaring it, you actually do need to do f of x squared and then minus the g of x squared. And that's simply because when you're doing areas of circles, you can't subtract the radiuses, the radii, and then find the area. You have to find the two areas and subtract them out in that order. Okay, so here's an example where we have this region and give us a couple things here, and we're going to rotate it over the x-axis. So let's draw a graph here. I know what f of x equals x looks like. Looks like that. I also know what this would look like. You start up at 2, and you go down like this on both sides. But at x equals 0, we would be cutting that area off right there. So this highlighted area right here, we want to rotate that around. And so if you rotate that around the x-axis, you're going to have a shape that almost looks like, it's hard to describe here, kind of like a junior mint, because you would have a circle and then it would kind of go in the middle right there. But it's really hard to draw a 3D shape like that. Okay, so the point here is we need to know what to integrate over. So what's point A? That's 0. Point B, well, we have to set them equal to each other to figure that out. So I'm going to add x squared over, subtract the 2, factoring that gives me positive 2, x minus 1. So my answers are negative 2 and 1, and I know negative 2 is down there, so I'm going to be doing 0 to 1. So let's set up the integral. 0 to 1, pi. Now it's going to be big R squared minus little r squared. And the function that is above the big R would be g of x. So right here we're going to be doing 2 minus x squared squared minus little r is just x, so that would be x squared dx. Alright, to clean this up a little bit, I'm going to put the pi outside. I'm going to FOIL this right here. 4 minus 2x squared plus x to the fourth. Sorry, that should be 4x squared, I believe. Okay, and then we're going to be subtracting an x squared. And I'm just going to rewrite it one more time to be careful here. 0 to 1. I'm going to put the x to the fourth in front. It's going to be minus 5x squared plus 4 dx. Alright, this is really just the number crunching part. So we have a pi out front. I got an antiderive. It's going to be 5x to the third divided by 3, and then 4x here. Now, if I put a 0 in, my result will be 0, and so I'm going to subtract a 0, which means I don't have to worry about it. So this is going to be pi, this is going to be 1/5 minus 5/3 plus 4. Excuse me. So, to work with this, normally I do minus 1 2/3 plus 4 1/5. So think of that as a negative. Now 4 minus 1 2/3, I'm thinking of that as 2 1/3. But I have to add 1/5. So let's think about this. This would be 7/3 plus 1/5, which is the same as 35/15 and 3/15. Alright, so that would be not the prettiest number, but 38/15 pi. And I guess you could write that as 2 8/15 pi. Okay, so there are cases like this one where after you set it up, you can actually work through it just fine without a calculator. But in general, for your homework, you should be checking your work once you get to the very end. And honestly, there are times when you can't just do it by hand, so you might have to default to your calculator. And the good news is that on an AP test, most of the time, they let you set this up, and they don't actually have you evaluate it, or they just have you use a calculator.